In the first part of this video, I'm going to explain what a tornado graph is. In the second part, I'm going to show you how to make a tornado graph using precision tree. I'm going to use as my example the Freemark-Abbey model that we developed earlier in the class. Freemark-Abbey had a choice to make about what to do with their Riesling grapes. They could harvest them now, in which case the consequences were reasonably certain, or they could wait, in which case they would take a risk. After analyzing the situation, most of us judged that Freemark-Abbey was better off waiting, largely because the expected value of waiting, $35,640, was greater than the expected value of harvesting now, $34,200. The difference in these expected values is based on a number of assumptions. We identified three as particularly iffy, and I've highlighted them here in yellow. The first is the probability of a storm. The second is the probability of mold given a storm. And the third has to do with the value of the watery Riesling grapes that we'd have on our hands if there was a storm but no mold formed. The tornado graph I made enables us to examine the correctness of our decision given the underlying uncertainty we have about these assumptions. My tornado graph allows for the possibility that each of the probabilities is off by as much as half. So for example, the probability of mold the true probability might be as low as 20% or as high as 60%. With regard to the watery grapes, I consider the range of possibilities from $12,000 to $24,000, which seems to encompass all the possibilities that were mentioned in the case. Here is the tornado graph. What you can see is that the expected value of weighting, listed on the horizontal axis, varies the most with the probability of botrytis mold, varies a lot less with the value of the watery grapes, and varies the least with the probability of storm. The variance is given in table form as well, so that you can see the quantitative changes. So with regard to the probability of mold given a storm, the expected value of weighting can be as low as $30,120 when the probability of mold is just 0.2, all the way up to $41,160 when the probability of mold is 0.6. You read the output for the other assumptions in a similar way. An important point is that the only time that the expected value of weighting goes below $34,200, that was the expected value of harvesting now, is when the probability of mold is very low. For the other two assumptions, the expected value of weighting, no matter how optimistic or pessimistic we are about the values, stays above $34,200. In this sense, the only assumption to which our decision to wait is sensitive to is the probability of botrytis mold. Now let's return to the decision tree, and I'll show you how to make a tornado graph. To do so, go up to the precision tree menu, and then over to the sensitivity analysis button and press that. The box that pops up has essentially three parts corresponding to the three steps that we need to take to get the graph. The first part is the output section, and that's where we're going to enter the valuation, the cell valuation of the decision we want to analyze. In this case, we want to analyze the expected value to weight, and that's in the cell with the 35,640. The second section is the input section, and that's where we're going to put the assumptions. And then finally, in the third section, we're just going to indicate that we want a tornado graph. So let's start with the output section. Under type of value, change to the spreadsheet cell. Generally speaking, you're going to want to enter a specific cell. We then put the cell into the next line. In order to do so here, if you want to point and click, you got to use this little button right here. and then you click on to D15. Hit OK. Let's give the cell a name, and actually it's guess the cell name I want to use, the expected value of weighting. If you don't have that in, you can type it. Next we go to the inputs, that's the assumptions, and I'm going to clear this section so we can start new. We're going to add the 3 assumptions one at a time. You hit the add button. The first one we'll put in is the probability of storm, so we just click on the probability. When we hit OK, a second sensitivity input definition box comes up. We'll put a label in there. Now keep in mind that these labels are going to show up on your tornado graph, so you want to make them descriptive. I'm going to put in P storm. The base value is just the current value that we have in probability. That's 0.5 or 50%. And then we have to indicate what we want the variation to be. That is, how far below 50% do we want the tornado graph to consider, and how far above. The present default is to put in those variations in terms of percentages, and that's, I think, is okay here. I use plus or minus 50% to get the tornado graph that I just showed you. So I'm going to do that again here. The steps 10, I wouldn't worry about that. That's just to center the graph. I just leave that alone. And then I hit OK. And when you do that, you get back to the sensitivity analysis box, and it's entered the assumption as one of the inputs. And then we just have to do the same with the other 2 assumptions. The probability of mold in E8, give it a name. I'm going to just call it P. botrytis. And given storm, so it's a conditional probability. It has a current value, and I also varied that 50%. So we're going to leave the percentage change for the base value as is, and I varied it from minus 50% to positive 50%, and I hit OK. Final input that we have to put in is the value of the watery grapes. And here, in putting in the variation, I didn't do it in percentage terms. Instead, I changed the input to actual minimum and maximum. So the actual minimum is $12,000, and the actual maximum is $12,000, and the actual maximum is $24,000. And again, we leave the 10th step alone. And that completes the inputs. The only other thing we have to do down below is indicate what kind of graph we want. The only graph I want today is the tornado graph, and so I'll mark only the tornado graph. And once you have that complete, you simply hit OK. Takes a moment, and there is the tornado graph.